Today we're going to talk about the volume of 3D shapes. So the shapes we're going to look at are prism, pyramid, cylinder, cone, and sphere. And some of the terminology you're going to see, a capital B represents the area of the base, an H represents the height of the figure, which is going to be perpendicular to the base, and of course R over here is going to be the radius. So let's take a look. We're going to start out with this rectangular prism. We name a prism by the shape of its base. So rectangular prism, honestly, all the sides are rectangles, so any side could be the base. I'm just going to choose this one for right now. So to find the volume of a prism, I need the area of the base and the height. So if I made this part the base, notice it's 3 by 5, so the area of the base is 15. The height is going to be the distance between the bases, so 9. And 15 times 9 gives us 135 cubic inches because volume is in cubic inches or cubic units. The next prism is a triangular prism. So notice this is the base and it's a triangle. So my height is going to be the distance between the bases, and my capital B is going to be the area of this right triangle. Notice I told you it was a right triangle. Also, if you think about this 4 goes right there. If you think about your Pythagorean triples, 3, 4, 5, does make a right triangle. So there's the right angle. Your base is 1/2, 3 times 4. So capital B is going to be 6. And then height, the distance between the bases, is going to be 10. So the volume of this triangular prism is 60 cubic units. Another triangular prism in number 3. So the triangle is the base. So we're going to find the area of the base, which is this triangle down here. Well, notice we gave you the height was 4 and the base was 8. So 1/2 of 4 times 8. The area of my base is going to be 16. The distance between the bases is 20. So the volume of my triangular prism is going to be 16 times 20, which should give me 320 cubic centimeters. So those were some examples of prisms. A prism could have a pentagon for a base, an octagon for a base, and we'll practice finding those areas as they come along. Next up, we have a pyramid. When it says a square pyramid, that means the base is a square. So all of those sides are equal to 5. My volume of a pyramid says 1/3 base times height. A pyramid is actually a third of a prism. So the height of my pyramid from the tip perpendicular to the base is 7. And the area of my base, because it was a square, is 25. So 1/3 of 25 times 7 is going to give me a lovely number. It's going to be 58.3. And if you get this as a decimal, but you wanted to not round off and kind of leave it a little bit more neat, you could hit math, and the first button changes whatever you had to a fraction. So it's also equal to 175/3. I would take either of those answers. This one looks a little more clean. That one's rounded off. Let's look at our cylinder. The volume of my cylinder, it's still like a prism, capital B times H, but since my base is a circle, I know the area of a circle is pi r squared times H. So if my diameter is 4, that means my radius is 2, my height is 9, and I just plug my numbers in. Now with circle bases, with a cylinder, a sphere, and a cone, we're probably going to leave them in terms of pi. So in other words, in your calculator, you can do 2 squared times 9, which is 36, and then we're just going to call it 36 pi. cubic centimeters. So if you see the directions that say in terms of pi, that's what that means. It means don't put the pi in the calculator to stick it on at the end. And by the way, all of these formulas are on your formula chart. Here they are. Volume, they're all right here. Cylinder, pi r squared h. Cone is going to be 1/3, just like a pyramid was 1/3 of a prism. And then we have the formula of a sphere. You get to use this on your test, so you don't have to memorize any of these. The volume of a sphere, that's a fun formula. 4/3 pi r to the third power. So in this one, I told you the radius was 8. So we're going to go 4/3 times pi times 8 to the third power. So I know I'm going to have an ugly decimal on this one, so I'm just going to leave 3 on the bottom. 4 times 8 to the third power is 2048. And I can just leave the pi right there on the top. If you were to multiply this out and get a decimal, you would do 4/3 times 8 to the third power, and that would equal 682.667 pi. Don't forget the pi, cubic inches. So I like leaving it as a fraction because it's nice and neat. This is also the rounded off version, but don't forget the pi. All right. Next up, I think we have a cone. Find the volume of the cone. So my cone is going to be 1/3 pi r squared h. So you take your cylinder and divide it by 3. Now, this 15 is pointing to this line. The height of my cone is the one that comes down here. So I'm going to have to calculate the height of my cone. This one is called the slant height, and we're going to use that when we do surface area. But notice that my height and my radius are the legs, and the slant height is the hypotenuse. So I'm just going to say h squared plus 12 squared equals 15 squared. And we're going to solve for what the actual height of the cone is. So this is going to be 15 squared minus 12 squared. Oop. And square root of 81 is 9. So the height of my cone is 9. So I had to do a little calculation there. And now I can just plug my numbers in. Volume is 1/3 pi. Radius was 12. And my height was 9. So I can multiply those out. 12 squared times 9 divided by 3 is 432 pi cubic centimeters. Volume's always in cubic units. So the difference on this one was they didn't give us the height. We had to calculate the height. So that could happen. All right, next up, an ice cream cone. What's your favorite ice cream? I'm going with mint chocolate chip. A cone is filled with ice cream with a scoop on top. Find the volume of the ice cream. So for this, we have our cone that's filled with ice cream plus half of a sphere, which some people like to call a hemisphere. So we're going to add these together. This is called a composition of figures put together. All right, the cone, 1/3 pi r squared h. The sphere is 4/3 pi r cubed. So let's plug in what we know. My radius is 4. My height of my cone is 10. And for my sphere, all I need there is my radius, which was 4 to the third power. Okay, let's see what happens here. 4 squared times 10 is 160 pi over 3. Because I know that doesn't divide nicely. I'm just going to leave it over 3 for now. And the same thing here. We could put it in, if we use alpha y equals, your calculator will leave them all fractions for you. So 1/2 times 4/3, don't put the pi in yet, times 4 to the third power. So I get 128 pi over 3. I wonder if I can add those together. They do have a common denominator. So what's 1/6? Let's put them back in fractions. 160 over 3 plus 128. Let's try that again. Put them in as fractions. 128 over 3. And I'll delete that. Let's see. Oh, 96 pi. And that would be cubic centimeters. Would be how much ice cream. That's a big ice cream cone. All right, the last thing we're going to look at are these. We're going to plot some points, and we're going to revolve our shape around one of the axes. So let's see what happens here. A is 0, 0. B is 3, 0. C is 3, 6. And D is 0, 6. So we have a rectangle. Now the directions ask us to revolve the rectangle around the y-axis. Okay, remember, this is my y-axis. So we're basically going to take our shape and we're just going to pretend like it's 3D, and we're going to rotate it this way. If you've ever gone through a revolving door anywhere, you've seen what happens here. So if I revolve this way, look what happens. What's the 3D shape? It's a cylinder. Now be careful, if you rotate this around the wrong axis, your radius and your height switch places and it'll mess you up. So make sure you know which axis to rotate around. The radius of my cylinder is 3, and the height of my cylinder is 6. Find the volume. Well, once I know those two things, I just plug them into pi r squared h. So 3 squared times 6, that's 54 pi. And then whatever units we would put on here, cubed. And in class, we'll watch a video of this rotation, kind of help it make a little more sense. All right, this time we're going to plot a triangle. We'll start at 0, 0. B is going to be 3, 0. And C is going to be 0, 6. So here's my triangle. Now be careful. This time I'm rotating it around the x-axis, which is here. So I always like to first, I'm just going to reflect it over. And then as I revolve it around the x-axis, I hope you can see that that makes a cone. So revolving a triangle makes a cone. Revolving a rectangle makes a cylinder. I think of this one like the revolving door that used to be at the old Frisco Library. The cone, I got nothing, but we'll show you a video of that one. Now the radius and the height, again, if you revolve this around the wrong axis, you're going to mess up your radius and height. So on this one, the radius is going to be the 6, and the height is going to be 3. So we're going to plug those into 1/3 pi r squared h, just like our formula. 6 squared times 3 divided by 3, I believe that's 36 pi. So now you have some practice to do on volume, and then get ready to take your check.